series. And good evening, Ajay ji.
Good evening, Professor Huda. Quite some time, all well.
All your best wishes. So, dear participants, welcome you for this 71st webinar of IEEE VVI Camp, along with all other premier professional societies today evening. The time of the webinar is about to start. You may keep writing your name, your affiliation, and your city from whichever city you have joined. So in between, you keep on writing this. For today's program, as usual, Ayushi is the host, is the new member in our team since last 4 or 5 months. Yeah, please keep writing your name, your affiliation, and your city. Chat window. By the time you will get conversant with this chat window also, because this chat window is very important tool. Through this chat window only, you will be getting the link for filling up the feedback. After which means based on filling up the feedback, you will be in a position to join. You will be in a position to generate your certificates. I could see very, very senior participants amongst attendees also, and amongst the panelists, General Chandele, the former president, national president, Institution of Electronics and Telecommunication Engineers, IET is also there. Chandele sir, if you are hearing me, good evening to you. But many of my core friends who believe that computer science is the core subject are not attending today because they think that 5G is a topic of telecom people. Yeah, might be. Anyway, it is up to their interest. Which topic seems to them close, they should attend. If topic doesn't seem to them closer, they may choose out. आयुषी टाइम हो गया है?
Yes, sir. Shall I start?
Oh yes, please start.
Okay, sir. A very pleasant evening to all the distinguished panelists and participants. Bharati Vidyapeeth Institute of Computer Applications and Management, BVI CAM, in association with Computational Intelligence Society, chapter of IEEE Delhi section, Computer Society, chapter of IEEE Delhi section, Technology and Engineering Management Society, chapter of IEEE Delhi section, Man, System, Man and Cybernetics Society, chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity Group of IEEE Delhi section, Life Member Affinity Group of IEEE Delhi section, Inter-Society Relations Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology Standing Committees of IEEE Delhi section, with the associations Computer Society of India, Institute of Information Technology Professionals, IITP, ISTE Delhi section, and IETE Delhi Center as technical collaborator welcomes you all to the webinar on the topic Elements of New 5G Radio Access Networks, Open, Cloud Native and Intelligent. It is a moment of pride and honor to announce that we, with united hands, mark special contribution for the monumental occasion Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence by organizing the thought-provoking sessions for our better future. This webinar is an initiative for the celebration of Azadi Ka Amrit Mahotsav. 5G is the network on top of which real virtual reality can and will be built. Well quoted by Christian Hansen, founder of Sparker. The foundation of the new 5G network being built and deployed is focused on bringing the cloud concept to telecommunication networks. A flexible, scalable, and programmable radio network with novel cloud native network elements that stimulates innovation by opening to developers via cloud style service programmability while masking sophisticated real-time sensitive information. On specialized cloud platforms, 5G radio capabilities is available. If this sounds like hyperscaler technology, which has resulted in massive cloud adoption in the enterprise, consumer, gaming application space, you are right on the track. This webinar will cover the fundamentals of disaggregated radio network as well as the techniques and the current design thinking for making networks intelligent. This session will help participants understand the cloudification revolution of 5G radio networks and why it is one of the most significant changes occurring in the telecom industry. This webinar will also discuss the real-time issues, case studies, and mitigation policies. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I welcome Professor M.N. Huda sir and request him, Professor M.N. Huda sir, Bharati Vidyapeeth Institute of Computer Applications and Management and Vice Chairperson, IEEE Delhi section to address the participants with his inspiring words. Please, sir.
Ayushi, am I audible?
Yes, sir.
Oh, yes. In between, I got offline. Huh? Good evening, one and all. Dear participants, it is a matter of great privilege and opportunity to welcome today's valued speaker, Mr. Arnav Das, the Vice President, Capgemini Engineering, and specifically the Center of Excellence which Capgemini is having. I take this opportunity on behalf of IEEE, on behalf of all other professional societies, to welcome him in this IEEE BVI Camp 71st evening webinar series. I also take this opportunity to welcome all my friends from various professional societies who have collaborated with us for the purpose of this evening webinar. I have here General Chandele, the former president, IETE, and my friend Mr. Ajay, the chairperson of Industry Relations. Dear friends, I also take this opportunity to welcome all the participants from different parts of the country and abroad for this particular webinar. Participants are very important and their temptation with which they keep on waiting for a new topic to be delivered by some known expert on this platform is a matter of great encouragement to all of us. The today's topic which has been organized is primarily a 5G radio. And if I tell you in one word, it can be summed up as the cloudification of telecom domain. We have seen that in last almost a decade, the cloud environment has penetrated almost in every sphere of technology. Let it be the software domain, let it be platform, let it be infrastructure, let it be retail, and let it even the hospitality, etc., etc. Now it has been realized that with the same magnitude the transformation is to be realized, the telecom industry also need to extensively use the cloud environment. And that's how if 5G in letter and spirit we are going to realize, then cloudification cannot be ignored. And that's how we believe that the cloudification, once it is implemented, it will not only be a kind of generic technology based transformation for 5G radio, rather will also add the kind of the intelligence which will certainly improvise its overall performance. And for this particular topic, for having this background, we have invited Mr. Arnav to tell us that how and in which way 5G radio is going to transform the entire telecom domain. Friends, this webinar series which we had started
last year in the month of May 2020, in the backdrop of the first wave of COVID, is being continued most of the time on weekly basis and sometime on alternate week basis. This is 71st of that series. The purpose of this webinar was that when from March onwards, it started disturbing everything in and around us, the huge disruptions has occurred. So we realized that if we do not involve fellow professionals from different parts of the country into overall learning process, possibly the people will go into depression. And that's how understanding this, that if we keep engaging fellow professionals into a learning activity, so at least we will be in a way mitigating the negative impact of the COVID-like pandemic. And with that objective, we started and we are continuing. When we are talking this, all of us are also aware that the fourth wave of COVID is knocking our door. We do not know to which extent this is going to again disrupt each and everything in and around us, or we will be in a position to gracefully mitigate with this. But nonetheless, we should be prepared enough. We have seen the devastations happening all across the world and particularly in the country during the second wave. And possibly that devastation had made us to learn many things. And because of that, the third wave, we could have handled and we had mitigated very successfully. So wish you all the best. Stay safe, stay healthy, stay vibrant, keep learning despite disruptions in and around us. And with this note, के वक्त नाजुक है, संभल संभल के रहिए. ये सेकेंड वेव में दो पंक्तियां लिखी थी मैंने, जो वापस चौथे वेव की दस्तक जो आने की दस्तक हो रही है उस पर याद आ रही है कि वक्त नाजुक है, संभल संभल के रहिए, और जब तक न हो बहुत जरूरी घर के बाहर न जाइए. So thank you so much. Let's all put our energy together to welcome Mr. Arnab for this wonderful topic, which is going to help us to understand that how and in which way 5G radio is going to transform the telecom network and add value addition to all of us. So thank you so much. Over to you, Ayushi.
Thank you, sir. Thank you for always motivating us. I would now like to request and welcome amongst us our expert speaker with an e-bouquet. I welcome you, Arnab, sir.
Thank you so much.
Thank you. Mr. Arnab Das, sir, Vice President, Advanced Connectivity Center for Excellence, Cape Gemini Engineering. He has total of 32 plus years of experience and 25 plus years at Cape Gemini. He has played diverse roles across engineering, business, innovation, and pre-sales. Arnab sir also has his hands on enabling business outcomes, improvement opportunities for global technology products and services customers, large enterprises, service providers, and telcos across multiple industries using advances in intelligent and connected devices, IoT, IoE, and IIoT. He leverages advances in device engineering, edge compute intelligence, ML, and analytics. Mr. Arnab is running the advanced solutions offering business, owning the strategic client relationships, and responsible for IoT and edge solution offering P&L end-to-end. He has delivered multiple technology sessions across platforms and still a core techie at heart. I welcome the great intellect to this session. I would now like to request Sir to please enlighten the house. Please, Sir.
Thank you so much. Thanks for the wonderful introduction, and particularly Professor Hoda. Very inspiring words there. And I completely agree that in this environment of COVID, these kind of platforms where we can come and share whatever little experiences and awareness we have, and listen to and get feedback from the community of fellow engineers. It is very inspiring, and I think it's a very positive initiative. So thanks a lot to the organizers. Thanks to Ajay for connecting me to this opportunity. If I may request, I'm not sure if my presentation is still visible. We can switch over to the presentation mode, and then I will get started with the presentation.
So please share the presentation.
Okay. Yeah. All right. let me know if.
Yes,
we
sir.
can.
Yes, sir. We can see it.
Perfect.
It is
All right.
visible.
All right. And I guess my audio is also okay.
Yes, smooth, sir. It is smooth.
Perfect. All right. So, so this particular topic for today evening is really, as has been already observed in the introduction, is really about the new architecture of deploying 5G networks and how the concepts of software, concepts of virtualization, concepts of how a data center works, things that we are very familiar with maybe as consumers. We all do shopping on Amazon or Flipkart. We all watch, particularly so in COVID era, watch movies and entertainment on OTT platforms like Netflix and Amazon Prime. The real technology that is powering all this is really microservices, scalable architectures, elastic services, and things like that. So the telecom world has been out of this realm of new software paradigm for a long time. But starting with 5G, we will see how the network really has the technology of 5G has really natively adopted the concepts of cloud engineering to provide connectivity. Essentially, the purpose of any system like 3G, 4G, 5G is to give you and us, all of us, reliable connection. So how the connectivity service is implemented on cloud native principles. That's really the purpose of giving an introduction of how this new technology is coming into telecom world. And hopefully this will trigger some interests which can always be used to create further research if the topic is sounding interesting. So we will see here a little bit of a demonstration of how the networks have evolved. So we've come up with a simple representation of the generation era. So you see something called as network 1.0, call it 2G, GSM, the small function phones that we used to have in maybe in early 90s. I think in India, it started in 1990, perhaps, the cellular services. So the network would consists of essentially hardware, a lot of hardware boxes, which are today, they are called as PNFs, physical network functions. Why? Because there are other things nowadays, which we will see soon, such as VNF and CNF. So the network really consists of switches, routers, radio antennas, wires, everything. Everything is very hardware. And the people, the technology companies that would make these solutions and products, and they would sell it to the telecom operators. This whole ecosystem was very closed. If an operator like, let's say, Airtel buys a radio network or a 2G network from a vendor, they would have to pretty much go with, say, somebody like Ericsson or Nokia or one of those typical equipment vendors. So that's why these vendors would come in with their hardware with silicon systems, etc., and implement the network. And pretty much the network is owned by them. So that is how typically a 2G world it was. Now, as we started moving, as the networks needed to cover wider spans, more subscribers, very soon it was realized that if you have only physical boxes and devices, it is difficult to scale networks. So concepts of bringing in software so that if the box is constant, you can add and more software, which is relatively easy to do than to introduce a new hardware box itself, then you can scale the capacity. So that is where the first generation of taking elements of a connection system and making it more software centric, things that can run as programs. So that journey really started from the 3G world, but it was still mostly in the core part of the network. It didn't touch the radio part of the network where physics communication channel and how radio signals propagate and how you capture the signals and process it still is done very much in silicon, in hardware, in chips. But the rest of the network, which is about subscriber data, subscriber services, those started becoming more and more software centric, right? So that is network 2.0, which is a little bit hybrid. It has some elements of the network, typically the radio network, which is still boxes, and some element of the network, which is, let's say, the management software, things that you can put some software to observe how the network is performing. So a lot of software started coming in there. If you want to launch a new service, SMS service, VAS services, all of that became very much software centric, and on the fly you could add and remove things. So that is network 2.0. But still, the issue here is if certain parts of the network is still closed, it is still based on boxes that the vendor provides, it becomes a hybrid network. So that means you get some amount of scalability and technologies like OpenStack, etc. But then still certain parts of the network is still closed, and you are at the vendor's, at the mercy of the vendor to really go and add new capability, new capacity in the network, right? So, but the journey definitely going from 2G to 3G to even 4G world is what you can characterize as network 2.0. But towards after the launch of 4G, which is the service that most of us use today, is very commonly 4G in India. Of course, the 5G spectrum is being now being licensed for sale very recently, as recent as the last 2 weeks. But so that means pretty much what we use today is still 4G. A lot of the network infrastructure which is used to provide 4G wireless connectivity to subscribers is consisting of partially virtualized functions, the transport layer, the optical fibers, and the switches which sit on the optical fiber, the radio antenna, the connection of the antenna. They are still, there is still a lot of proprietary hardware which runs there. But starting with 4G, the virtualization journey had started. Now, when 5G standards and specifications were being made, and it is something called as release 15 onwards, release 15 of 3GPP and release 16, release 17, so on and so forth. These are all the 5G specification. Pre-release 15 is 4G specification. So release 15 onwards, when the 5G specification first started being made, the design principles right from day one, grounds up, was to build new type of network. 2G, 3G, 4G essentially was taking the technology and improving it. 5G is an inflection point where everything, starting from the radio network to the core network, to the way the services are designed, everything was redesigned grounds up to bring in more softwareization, to bring in more cloud native technologies in it. And this is really the genesis of future network. 5G, 6G, already work is going on 6G onwards. So this is going to be a completely new type of network, which is designed to be software everywhere. And we will see what that means in the next few slides. But essentially here, if you take a radio function, yes, the radio waves will be hardware because you cannot put software to transmit a signal from point A to point B over the air. That is still hardware. There is an antenna, there is a transmitter, there is a receiver. But once the signal is received, erstwhile systems would be doing a lot of processing of the signal because it needs to be very time sensitive in hardware. Today, all of that, or most of that, 90% of this functionality can be achieved in software. And the 5G specifications are built grounds up to accommodate that. Even things like layer 1 function where you have software defined radios, SDRs. On top of that, you have functionality. Some of you who are studying communications or many senior members are there, of course, veterans of the industry. L1 functionality, the MAC layer, which is L2 functionality. A lot of this work would happen in silicon, in FPGA. Today, these elements are realized through microservices, through time-sensitive microservices, which are essentially software elements which run in containers, right? So today we are seeing building out of 5G networks as Network 3.0, which is more software. And we'll get into a little more details of, what are the nature of the software, what are the challenges, etc. Now, what does this bring in? The moment you have proliferation of software, you can have multiple vendors. You can have the functionality of the radio coming from one vendor. You can have the functionality of higher layers coming from another vendor. And you can put all of this together through software integration and deploy networks. And then when the capacity has to go up, you can add in the software some capability to increase the capacity that in dynamically, and then reduce the capacity to reduce, say, for example, power consumption very easily. So moment you disaggregate hardware and software, networks become much more flexible and dynamic. And but what is the journey eventually going to be? And this is where we all see, of course, we have all read, and as consumers, we have experienced, and every day we are experiencing AI/ML, which is artificial intelligence and machine learning. Like whenever we go and do a search in Google, and the next time we open up Facebook, we see that there are recommendations, from the engine about ads of products which are related to that search. Or let us say on YouTube, when we go and we do certain types of search, let's say technology of 5G, you do 1 or 2 or 3 searches. After a while, the system, YouTube, starts giving you recommendation of, well, this is more interesting information on 5G, maybe you want to read this, etc. So similarly, all of this is driven in the software world. It is driven through AI/ML. Now in telecom world, pretty much up to 4G or starting of 4G, somewhere in network 1.0, 2.0, there was hardly any AI/ML. Starting end of network 2.0, and most certainly in network 3.0, the new design of 5G system has incorporated in the implementation architecture, that protocol stacks, the functionality of the OSI layers, the capability to add AI/ML. Why? Because in future, the vision is that networks will be intelligent. Networks can organize themselves and put their functionalities together on their own and become self-sustainable, so that the amount of effort and cost it takes to design, implement, and run a network, you have to operate a network, operation centers, which are there to monitor the network quality, etc. All of this functionality, it should be possible to run it through software, which are, automated operations, self-healing networks, sustainable networks that consume, let's say, less power, and consume power only when it is needed, so that it is, net zero or carbon neutral or whatever. So in order to do this, you need a lot of algorithms to run in different parts of the network on its own. It is not humanly possible to run networks as it used to be in network 1.0 or network 2.0 and still achieve these goals of, automated operations and sustainable networks. So AI/ML plays a very important role in bringing this reality to reality. And 5G has been designed to incorporate AI/ML in its various operations, and we'll see a lot of that in the next few charts. So where are we today? As I was mentioning, in most of the countries now, new 5G networks have started coming in, but there is a lot of 4G still, which means we are at the inflection point where physical networks which are single vendor and locked in networks, are opening up. There's a lot of virtualization which has come in. There is probably 30% of the elements of the networks today are cloud native, especially networks which are newly built, completely built without any existing or legacy infrastructure in it. So having said that, what are some of the key themes that are driving networks today? When I want to design a network, whether it is the broadband service on which this WebEx is running. You know, the service provider in our locality, whoever is providing, is probably Airtel and Jio and others. So the fiber optic to the home, you know, that is the access network. Or if I use my cell phone as a modem and I run it, use it to communicate wirelessly. So this is all access networks. So then comes the core part of the network, right? Where all the signals from different subscribers are coming in and they're being processed, and then it is deciding that this video stream goes to this channel, this incoming video stream needs to be given to this subscriber. So the core of the network. So any part of the network, whether it is access or core, there are some common themes that are being talked about whenever, and each of these topics are very, very detailed. You know, you can have extensive amount of research, extensive amount of technology that is changing almost every day in each of these topics. So disaggregation, this is an important concept. What does disaggregation mean? It means how the hardware and the software. Earlier, there would be a single box from a single vendor. You take the entire box with hardware and software together. Today, the hardware can come from one vendor, could be an Intel server or anything, and the software can come from different vendors who are providing 5G software. So disaggregation and how these different units from different vendors can work together, because eventually the disaggregated network needs to work together also. The deployment itself, in the previous networks, you would have to do a lot of planning, that you would go to a remote site, put a box, and then come back and you know, test the signals and all that. Today, it is seen that you can really sit at your terminal and order the hardware and the software from different vendors. You can order the installation to be done by a certain vendor, and then remotely sitting from your operation center, you can download a lot of software, test it automatically, and make sure everything works. So there's a lot of flexibility in deployment. The network functions itself, we will see a lot of that: access function, edge function, core function. A lot of that is now disaggregated. It's all software which can run on any hardware. It is no longer required that the software, networking software, needs to be running on a particular type of hardware only. Similarly, openness, which we will see a lot of, how disaggregation and openness, so that you can bring in different types of vendors and you can bring the cost down. You know, moment you open it up, you no longer have only one vendor who needs to provide everything. So there will be competition, and therefore the service cost, eventually as subscribers or users, the service cost will come down. And there's a lot of automation now. We know about DevOps and CI/CD, which is continuous integration and continuous deployment, where really since you are bringing in a lot of software, you know, there is software in every part of the network. The software files can get transmitted. You don't need a very rigid environment where, you know, you take a box, put it in your lab, test it, and then from the lab you put it in the network. You can have the software coming in from different software vendors. It's like receiving emails almost. And then the software gets processed, it gets tested, it gets checked for security and vulnerability issues, all of this automatically. And if all the checks are passing, then it will get downloaded into the device which is sitting in the field, and the network can get a new service. So this is called DevOps. And in telecom world, this has been adopted now in 5G, even for complex part of the networks like the radio networks and so on and so forth. And eventually, let us imagine that I have installed a 5G antenna, okay, and it has got some software in it, and there's a box there, let's say a laptop, something like a laptop, which is an Intel server, which is running the 5G radio access function. Now, let us say that the subscriber in that area, you know, is moving around. Suddenly there is a lot of requirement from the subscribers to download data or download or watch movies, etc. But let us say at some other point in time, there are no subscribers. The radio signals no longer need to uplink and connect anything. Now imagine if I have some intelligence in the radio antenna to predict that I am likely to get a lot of download requests. So let me add more capacity in my radio waves and make it fatter so that the downloads work faster. And let us say I'm also able to predict that I no longer need to keep that fat pipe. I can make it a very small pipe and use the capacity of that radio in some other sector where there is likely to be higher demand. All of this intelligently, the radio antennas are able to figure out and use and optimize the power, optimize the service or the quality of service. So this kind of software is now possible today in 5G to be implemented in the radios. And this is where it is called pervasive intelligence. There are concepts of radio intelligence controller, RIC, and how it can use AI/ML models to control the functionality of the radio antennas to really behave intelligently and not have a very fixed behavior. In 2G, 3G worlds, the power levels, the orientation, the antenna optimization, everything is fixed. So whether there is a subscriber is there or not doesn't matter. I'm still radiating the same level of energy without any other consideration. But in 4G and most certainly in 5G world, there is a lot of software algorithms which control these kind of operations. So that is really pervasive intelligence and virtualization. Now, let us introduce, I'd like the opportunity to introduce something which is again very unique to 5G networks today, which is network aware applications. So what is that? So if you observe this diagram from left to right, what does the network consist of? There is devices which connect to the radio antennas, and then from radio antennas, wherever the antenna is positioned, you can put some servers right there at the antenna location, which is called edge compute. So this is what you see on-premise edge compute, and we'll come back to this topic. Why do we need edge compute? And then from the edge compute, the signals goes into the more core part of the network, which you see as the data center and public cloud, which is basically you're accessing internet and so on and so forth. So now, if you see, there is a lot of software which is running in the radio itself, what you see as 4G, 5G private networks, and then the core networks. And then on top of that, what you have is applications. Now, what are these applications? If you observe, look at the devices tower on the left-hand side. It is not just cell phones. Today, the 5G networks are designed to be extremely heterogeneous in the nature of the devices that are connecting to the network. It's not just cell phones where human beings are using the cell phones to, let's say, make a voice call, or let us say to access the internet, where a human being is experiencing some service from the net. Rather, there can be different types of devices. That could be a surveillance camera in an airport, which is continuously ingesting a lot of video, which is being transmitted to the network, and that video is being analyzed by some software to see, is there a security violation? Is there a person of interest that is passing by that I need to flag? Or the same network, you can have a lot of cars which are continuously connected to the network, and it is transmitting and receiving information, which are the so-called connected cars. Or you can see there is a AR/VR based goggles that you can wear, where you're continuously connected to the network, and maybe you are an industrial worker in a shop floor, and you are receiving instructions on your visor or the AR/VR glasses to do a certain operation on the production line. So there can be different types of devices that are simultaneously connected to the network, and each device has its own requirements. It is not, not just making voice calls. So therefore, the network needs to have applications which are network aware. If I am wearing a AR/VR glass, I need the application which is ingesting data to be aware that the quality of the network is going to be high, or suddenly there is some interference and disturbance. So the network bandwidth reduces. If the bandwidth reduces, I will no longer be able to display images on the VR glasses. So I should try to do video compression so that I can use lesser bandwidth and still try to display information on the glasses. So these are intelligent applications now, which you see on the top. The network now needs intelligent applications, which is network aware. It should know about the network. Is it how much bandwidth is available? What is the direction of the signal? Or what is the likelihood that the bandwidth will go down or go up, etc. So this kind of architecture is now possible. If you see the top layer, the applications which are intelligent network aware applications which can run on the device, run on the base station or the radio network, which is the second box you see there, or it can run on the edge compute. Everywhere in the network, you can have different types of application which is continuously probing the network and getting information from the network. And then using that information, it is changing its behavior based on the application. So these are basically possible because in 5G, if you remember, we talked about everything is software. There is a lot of software everywhere. There are API that are exposed to allow you to get this information from the network. So as a developer, if I have a handbook which tells me these are the API to get information from the radio access network, these are the APIs to get information from the core network, these are the APIs that gets me information about the devices, the power level, the nature of the devices. And I can use those APIs to write a smart application of my own and deploy it in the network, right? Now, 5G allows you to do that. This was not really possible in the era of 2G, 3G, 4G. So that's why 5G is truly software centric, truly API based, and truly developer centric. Of course, when I say this, it doesn't mean that it is not secure. The way that you can access the APIs, who gets access to APIs, if you are a malicious user trying to use the APIs to jam the network, there are safety mechanisms everywhere to prevent that from happening. But essentially, the network is extremely flexible, extremely software driven. It gives you ability to change the behavior of the network depending on whether you are having connected car users or AR, VR users, or a security or a video camera user, or really a combination of these. Certain parts, there are more video cameras, certain parts, there are more industrial workers. So based on these parameters, I can use the network in the most optimal way in that particular location because of this openness and because of the programmability of the network. So this is why they are saying that network 3.0 or 5G networks essentially is no longer a network, but a platform. It is a platform that allows you to develop applications and deploy and use the network the way you want and not a fixed manner. Essentially, 5G networks, because of all this flexibility, therefore, the same infrastructure, the same radio, the same architecture, basically, there's what's in a network. You have devices, you have radio, you have edge compute, and then you have the network core, 4 elements to the network. But the same 4 elements, the way it is used in different industries can change. So there's a lot of flexibility which 5G has introduced, whether it is designing a network which is intended to operate for, let's say, automotive users, things where millions of cars are continuously connected to the network, and the navigation systems of the car or the performance of the car, the energy, a lot of EV cars are there. So the battery utilization and the battery optimization of the cars, there are many things that can be controlled in an operation of a car through connectivity instead of programming it. So maybe you have fleets, a logistics operator who is running trucks. You can have fleets of trucks which are moving, and you are able to navigate the fleets in the more optimized manner through software. So if you are using 5G to do a connected car network application versus, let us say, something like a factory automation, where the plant itself, every part of the factory is connected through 5G. So because the networks are flexible, because the networks are essentially software driven, you can implement 5G in different industry fairly easily by bringing in specialization in the software without impacting all other parts of the network, right? The access, you can change the access to meet your purpose. You can introduce edge compute to meet your purpose of the industry. So this is very important part of new software-driven flexible networks as compared to the previous generations of network, which maybe wireless, for example, wireless or 3G networks were not at all reliable or usable in factory environment. You could not use 3G in a factory environment for many technical reasons. But in 5G now, it is possible to use it in a factory environment, in residential environment, in defense environment, different types of environments because of this flexibility. Now, let us get into a little more examples of how this situation is working out. For example, if you take a radio access network, so essentially, what does it consist of? It consists of the radio antenna itself. It consists of the baseband unit, which is very close to the radio antenna, and it is doing the signal processing. Now, in the traditional network, everything is proprietary. It is made by a particular vendor, and it will be designed. Of course, there would be some efficiencies, or there would be the selling proposition of that particular radio access vendor. But in virtualized approach, when you take every function of the radio network and you see which parts you can virtualize, you can bring software in. So the first generation of virtualized network is something called as vRAN, where the hardware became generalized, which means the hardware can come from one vendor, and then you implement certain parts of the software, which is doing the signal processing and all that. But typically, the hardware and the software vendor would work together and make sure that the software is working on slightly customized hardware. So you couldn't take the hardware from anybody, but yes, you could have two different vendors, one for hardware, one for software. But in 5G, now the standards, the interfaces between the software implementation and the hardware implementation is also standardized, which means you can bring in everything, whether it is a general purpose processor or GPUs, as it is called, which can handle software radio, which is the L1 or layer 1, a physical layer of the radio, and then L2 is working in a certain manner. So the interfaces between L1 and L2, all of this is standardized. So the hardware, software, everything is standardized, and potentially you can bring each layer of the radio network from different vendors and really put it together. Now, what is the purpose of this? Because the radio access network consists of almost 70% of the cost of a network. And if you can introduce multiple vendors, through standards interface, you can introduce multiple vendors who can come together, it will really bring the cost of the network down. And also because of the software, which is now standardized, you can put in a lot of automation and really bringing the capability of running your networks in a very flexible manner, largely through automation, through software. And that again brings down the cost of the hardware, and it brings down the cost of operations, which is the software part. So essentially, the radio networks are being designed by certain forums. If you would like topics for further research, look at what the work that Open RAN Alliance is doing, ORAN, O-RAN. So this particular alliance is really bringing in the standardization in every layer of the radio access network so that it is all softwareized and it can come from different vendors and still work together. So this is what is really bringing in the flexibility in the radio access network. Now, this diagram kind of shows a simplified view of what a softwareized radio access network might look like. So you would see that the functionality, the pure hardware functionality, which is the antenna, the RF signal, transmission, reception, that is encaptured in a device here called the radio access radio unit, which is the RU. This is obviously this can only be hardware, because this is where it is the electromagnetic wave transmission and reception really happens. But after that, there is an open interface. Any hardware-based radio unit can work with a general purpose, say typical like a Dell server or an HP server, where you will run the rest of the software, which is the so-called DU, distribution unit. So basically you have a data center here, which is the MEC, which is the edge compute. And within the edge compute, you run the rest of the radio capability, which is layer 1 of the radio, L2 of the radio, L3 of the radio. All of that runs in this distribution. So any RU from any vendor can work with the distribution unit coming from any other vendor. In 3G and 2G and even to a large extent in 4G world, this box here, the DU and the RU, they were all combined together, right, to work. And there was a lot of silicon or hardware specific implementation. Today, 80% of the software which runs on DU is basically software. It can come from different vendors who are following the Open RAN Alliance specification, right? Now, that doesn't end the story there. The radio access network itself connects the core through this architecture where you see centralized unit, you see the data path, which is where the actual user data is going. But what is more important here is, you have this hardware and software disaggregation. We talked about the radio unit and distribution unit. This is one level of disaggregation. But all of this software, again, through standardized APIs, remember we talked about API for intelligent application. Through standardized APIs are exposing their functions, their capabilities to the top, which is where the orchestration comes in. Now, this is all software. The distribution orchestration is all software. Let us take the example of something called a slice orchestration. So you would have probably heard about this term network slicing. So that means that if I have implemented the network, which means I have the radio unit, I have the data center, which is the far edge, the near edge, etc. Right? So I have implemented the physical network. So the boxes are all there now, let us say. And then on top of that, I have implemented this software, which is the radio function, central function, and the packet core function. Now, let us say I have two different enterprises. Let's say there is one enterprise, which is an industrial company, which is doing manufacturing, and they have a factory where they want the production line, all the machines in the production line to be connected to the network through 5G, right? So let's say I have this manufacturing company as a customer. Let's say I have another company, which is a logistics or a fleet management company who are having trucks who are each one of those trucks are connected to the network through 5G. And I have a fleet management application running on top. Both of these customers, the manufacturing company and the logistics company, are using 5G services from the same telecom operator, somebody like say Airtel or Vodafone or whoever. Now, the requirements of a fleet management application from the network versus the industrial company, will be different. The industrial company needs very low latency, very high reliability of the signal. If a machine is getting commanded that it needs to do certain functions, there needs to be a time limit in which it has to happen, etc. Whereas the fleet management needs coverage, that the trucks are always covered because they are moving around. It cannot vary. No matter where they are, the connectivity and coverage should be same. Secondly, maybe for fleet management purpose, there is a lot of data which needs to be uploaded continuously. The truck direction, the truck performance, the environment around the truck, which could be a video cameras on the truck, which is picking information. And it needs a lot of bandwidth continuously. No matter where the truck is, it needs a certain amount of constant bandwidth. So the requirement from these two companies are different. How the telecom operator can guarantee both these requirements simultaneously. And this is what something like an application like network slicing can do. This is really possible because it is all software. So I can create a slice of the network right from the radio to the far edge to the distribution unit and dedicate it to the industrial company. I can create another slice of the network, which is basically just a set of software instruction, which dedicates some resources for the trucking company, the logistics company, and I can give the relevant SLA, the service level agreement for these two companies in each of these slices simultaneously, even though the physical infrastructure that is being used by these slices is still the same. So this is one example of how API-based interfaces, which 5G grounds up has built, allows me to build all these applications on the top. You can see these are examples of network slicing, of smart radio application. SON is self-optimizing network. I can use the APIs to write intelligent applications which can implement self-optimized networks, etc. So this is one example of the power of disaggregated software everywhere 5G networks that the industry has brought in through the new architectures. Moving onwards, I want to spend a brief few moments on another very important topic in 5G networks today, which is edge computing. So what is edge computing? For this, actually, let me go back to the previous diagram. So if you see here, the radio unit and the front hall interfaces, the wires which come from the radio unit into the first point of entry into the network, where the radio signals are being processed. So it is getting converted from radio signals into, let's say, packet or IP signals, etc. Now, there are many applications which require, for purpose of running, the compute, where you're taking that information right at the source, closer, instead of traveling all the way up to the cloud, through internet. It goes to the entire 5G network, and then it goes to internet where there is a server, let's say a video server or a streaming server or something. So instead of going all the way out to the cloud and coming back in, if I can process the information that is being generated by the devices close to the source of the information, as close as possible to the device, then there are some very interesting set of applications that become possible, because I can give low latency, I can give guaranteed return path of signals instead, because I don't have the variability or unknownness of if I'm going all the way from the telecom network to the general internet and coming back, where I can have variable delays. But if I can do that information processing very close to the base station where the radio signals are being captured, then I can give all these interesting applications for the industry. And this concept of doing information processing as close as possible to the device is possible through something called as edge computing. And you will see the benefits of edge computing really comes in because I'm able to reduce maybe operational costs by implementing intelligent manufacturing applications, etc., which can run on edge compute servers. So let's give you a little more specific examples of how edge compute might work. So, for example, if I have an industrial worker, right? Going back to that example, if you see, and I am wearing that industrial worker at a shop floor is wearing a AR VR glasses, and there are some cameras fitted on the glasses. Okay, so as I move around, I am looking at the production line and what is the manufacturing process that is happening. So there's a lot of video being captured. Also, the sensors are picking up some information like maybe the temperature or other data, right? So there is video data, and then there are some sensor data. So the camera which I'm wearing on my glasses is continuously picking this and transmitting it. Now, what is my application? My application is that I take this video information and I process it. I can figure out that there is a certain part, there is a certain component on which machining is happening, and then the new shape of the component emerges, and then that gets fixed into, let's say, another component. So this is the manufacturing process. So the video can tell me whether the shape, the size, the orientation, etc. All of that, I can run a complex video analysis algorithm to figure out whether the production process is running properly. And let us say if it is not running, if there is an issue, then I automatically detect it in my video analysis and create some instructions which goes back to the machine operator wearing the glasses, and it appears on the glass as saying, okay, now this orientation, you change it, or the temperature on the production line has gone too up, so perform these following actions, right? Now imagine all of this needs to happen within a certain latency, like it can be no more than 50 millisecond, or it should be less than 10 milliseconds. So there is a particular time gap. Now, if I am running this application on the cloud, on internet, then this I can no longer guarantee that the algorithm will work and the instruction will come back and reach my glasses within that 10 millisecond. But if I can run it on a compute server, which is very close, maybe inside the factory itself somewhere, right, on a private LAN. So the edge compute architecture allows you to give the telecom operators to give dedicated compute resources for applications very close to services. And the same kind of concept now you can imagine for connected cars and things like that can happen. So again, now this is this is really possible. What is so special about edge compute? It was not possible to do this in networks of the past, where things were black boxes and specific devices of the radio and the core would come in from specific vendors. Today, the radio network elements can be coming in from a set of vendors, and the telecom operator can take the edge compute and really insert it in the network close to the source from another vendor, and it will all still work because of the proliferation of software. And these are some examples of how edge compute helps, particularly in, say, industrial automation, in doing predictive performance, where based on the data that is being collected, there can be algorithms running on the edge compute, which can say that, oh, this particular device, this machine arm, which is working, it is likely to fail. So reduce the speed or take it offline and do some maintenance and bring it on back. Because this is the power of AI/ML, which can be running as algorithms on the edge compute and do these actions. And where are the signals coming from? It is basically coming from 5G networks. Okay, so I will cover the last topic now of this presentation, which is about intelligence. And I'll take probably 3 more minutes for this. And then we will be, I think, open for question and answer for the last 20 minutes. So the last topic here is how does, if you remember that vision of network 1.0, 2.0, 3.0, and network 4.0 is really about AI/ML everywhere, where the network is, once the hardware is installed, then everything else, the network reconfiguration, network operations, everything is driven by AI/ML. So how does 5G concepts, how does 5G allow the concepts of AI/ML to really operate the network? Now, one of the most important elements of any AI/ML, of course, it is the algorithm, but what does the algorithm need to work on? Algorithm needs data. Basically, the heart of any model is data, which means I have a certain range of data, and I have done the analysis saying if these are my input data sets, the output data sets are this. So this is basically the in between. There is an algorithm which runs where it says that, okay, if if my radio signals are like this, it is most likely in these conditions, the radio signals will fade, or in most likely in these conditions, I need to change the direction of my antenna and create a new beam to give radio signal, to counter the fading of the radio signal. So basically, I can use the data to create input data to create instructions for the system to change its behavior based on the input data, which is basically another set of data. So how now networks have always had a journey. Networks has had a journey of how the network uses that in data to really control and manage. So earlier, the type of network operations would be script based. I take a certain configuration and I download it and push it down into the network and say that it will come up, and then I run another script to pull data out as much as I can and do some manual observations on it, maybe draw some graphs and charts and things like that. Now, if you see the graph on the right hand side, in 5G, over a period of generations, from the bottom up, from 3G to 4G to 5G, we are bringing in essentially a lot of capabilities to collect data signals from the network. Every piece of the network today is generating a lot of what is known as telemetry data, whether it is the radio antenna, whether it is the baseband unit, anything, everything, it is generating data. And 5G has defined every piece of the network, what kind of telemetry information is collected. 5G has also defined the data lake. You would have heard about this term, the data lake, where in the network you are storing the telemetry information or storing for some time, maybe not permanently, but certain time samples, you collect the data. So there are functions like NWDAF and things like MDAF and things like that. So you are basically storing the data. And then 5G has also defined every function, because it is all software, nothing is programmed. The behavior of every part of the network is in the specification. The behavior is not fixed. There are basically mechanisms like network exposure function, network application function. So there are APIs defined through which you can control the behavior of every function of the network. And what do those, therefore, as a developer, I go into the data lake of 5G, and through APIs, I pick the data, then I design a model, which is the cognitive AI-based model, let us say, and write my own smart application, which will allow me to control the nature of a particular part of the network. It could be the radio access network, could be the edge compute network, could be the core network, anything. So basically, we are moving from fixed rule-based network, which you see on the left-hand side, to evolution to judgment-based, model-based. Given the input data, the behavior will be different. It is not a fixed outcome every time. So this is really the AI/ML model of running the network. Now, the most significant impact, which has really come in because of this evolution, is the ability of the radio network to perform differently. If you take something like energy, so there is a power level, there is, you are powering the radio antennas and it is transmitting and receiving radio signals, right? Now, let us say that based on algorithms which are running in the radio network, I can manage the power level of the, when I should automatically reduce the power level, when I should turn the antenna in a certain direction and transmit very focused beams in a certain direction, when I should start doing multi-sector radiation based on the traffic patterns. So based on different condition, could be the weather, could be the number of users, could be certain events like a sports events happening at a certain day where the radio network in that but near the stadium needs to perform in a certain manner. And when there is no sports event happening, then the radio network near the stadium can be essentially in a lower power mode operation. So based on, without fixing any rules, I can really write algorithms which can use a lot of this data to control the behavior of the radio network. And why the networks today, the radio network today, as we talked about, is very open, is very software driven, and therefore it allows itself to be managed by algorithms. So that is really the key part, the key aspect of how softwareization and how API based and algorithmic operations of 5G network today are really possible. I think I will now pretty much end the session. We will see just a summary now. So basically, to cover all the topics we talked about. So ORAN Alliance, this is a reference for anybody wanting to do any further study. So please do a Google, or please, if you're already familiar, you might now want to go back and look at this. This is really defining how the radio network is softwareized, cloud native, what are the interfaces, how it operates. Edge computing is again a topic in itself, which is connecting the algorithm and the compute close to the radio network. So edge compute and open radio networks work together to bring flexible services or to run intelligent services on the network. And use cases, we talked about the connected car, the industrial operations. All of these use cases are really possible on top of the network because it's software everywhere. And that is what you see in point number 5. The economies of scale are possible because it's software. You can have multiple vendors. You can implement concepts like DevOps and CI/CD and really create intelligent self-operating networks, which are really transforming itself and transforming the way we consume the network services. So with that, I end the session today, and I'm open to questions and hand it back to you.
Thank you, sir, for the detailed and enlightening deliberation. I am sure that this session would have enlightened the participants about the real life applications, and they're more clearer about the concept now. Now, I would like to take upon the questions by your permission. May I, sir?
Yeah, sure.
So the first question is, with high degree of virtualization in the 5G network, does it mean cost of deploying the networks has come down, and roughly by what percentage?
Sure. Absolutely. The whole purpose and one of the major drivers of virtualization is to bring the cost down. But there are several elements of the cost. One is, of course, because you have to build the network, you have to procure the equipment and the software from different vendors. So virtualization is in a way allowing multi-vendor systems. So that means it is increasing the competition. You no longer have a single vendor, so that is bringing the cost down in even the what is known as the capex cost. Now, yes, the deployment cost itself, which means when you are creating this DevOps and CI/CD pipelines and bringing the cost down instead of going into each site and bringing it up. Now there is a lot of things that you can do remotely. And even when after you have deployed the network, every time there's a bug fix or a software upgrade or a new feature, you can really make those changes and turn it around very quickly. Now, to give you a sense in terms of by what percentage you said, so typically in the non-virtualized world, the networks, any new service deployments or any significant new service deployments, the software cycle of building it, testing it, and deploying it would run into 8 months, 9 months, or you would, at the best of the most efficient, would be having three cycles in a year. Today, you can update features into the network in matter of weeks. So you can see almost 30 to 50% time saving is possible in your release cycles, right? Now, by what percentage exactly you can gain the benefits through this software and virtualization and benefits of automation that depends on a little bit about the context of who the operator is and what their systems are, etc. But it is a significant number. You know, there are some papers by telecom operators like Deutsche Telekom, by Rakuten and others that you can refer. And there is also a paper by GSMA, which is a standardization alliance body, which has also given data from some of the operators. You know, so how much gains they have received through virtualization. So, but it is a very substantial and an impressive number. Of course, it can be argued anyways, because it depends on the individual operator's environment. But yeah, 20, 25%, 30% is what people are looking at.
Thank you, sir. Thank you for enlightening this. Next, we have the question, how will 5G support sustainable energy and energy efficiency?
Absolutely, this is a very important topic, and it's something that our customers also. It's a big opportunity for innovators, in fact, and as a country, I think we can do a lot of research and R&D and position ourselves in this world also. So it is particularly required because 5G causes what is known as densification of the network, which because you know the number of radio sites, the radio antenna sites can potentially go up. But also by that same token, since there is a lot of openness in the 5G network, you can build applications. I talked about how you can build applications that can do power management through software. So this gives you 5G network particularly gives you opportunity to really collect a lot of data from the network, use that to create energy consumption models, and then use the API mechanisms that the 5G network today provide to really go back and implement that in the radio access network. The core network pretty much doesn't. Anyways, 70% of the network's energy utilization happens in the radio access rather than the core. The data center, the regional and national data center, which runs the core, do also need energy optimization. But the biggest challenge is in the radio network, how you can bring the power consumption levels down or basically make it more intelligent to transmit only when it is needed. The good news is there's a lot of data which is available, and there is a lot of opportunity for models to be created, which can be used to bring the operational efficiencies of the network down. Now, again, if you are interested, there are many papers which are now coming up on optimization of radio access network data. You can look at topics like far edge data centers for radio networks, the power levels and utilization optimization of these things. And we ourselves as company today, we are working on several of these models. It's a source of revenue also for us to do consulting and projects to implement these kind of things in radio networks.
Thank you, sir. Thank you for deliberating it. I would now like to invite General Dr. Ajay Chandale, sir, former National President, IETE, to propose the concluding remarks. Please, sir.
General Chandale sir, are you there? Just a minute.
Chandale, sir, please unmute yourself.
Can you hear me now?
Yes, sir. Yes.
Okay.
Good evening,
So,
sir.
good
Please
evening,
propose.
everybody.
Yes, sir.
Good evening, everybody. First of all, thanks to our expert, Mr. Arnab Das, for such an excellent presentation. He covered the topics in a very lucid manner, and I'm sure it will be of a great benefit to our young students who are listening in. And as I noticed, we had over 200 attendees, which is very good. And also let me thank Professor Huda. He has carried out human service during this last 2 years plus of the pandemic. And I cannot tell you how much I really appreciate the work that you are doing by presenting.
Thank you so much.
For organizing these webinars. 5G, as everyone knows, I'll take more than a minute, Professor Huda.
Please.
5G, as everybody knows, is going to create a sort of a revolution which hasn't been seen for the last so many years. And as far as people like me who are associated with defense, this seems to bring in a lot of changes. And probably someday we'll request you to have a specific webinar on seeing what changes 5G will bring to the defense ecosystem. Right, Professor Huda?
Yes, sir.
And also, as you are all aware, we are all discussing the subject these days of the auction of the 5G spectrum. And there are different industry stakeholders who are staking their claim that if they get allocation, they will make, what a change they will make to the ecosystem. And particularly one stakeholder is the space associations. We've got the Indian Space Association, one organization, and the other is the Satellite Communications India, which is another organization. And these two had presented a white paper to the government saying that their band should be reserved, but which is not happening because the whole 5G band is being auctioned, to anybody. And of course, let's see how the auction goes, because the first lot, as you are aware, didn't go well. Now, Mr. Arnab Das, are you there still? Yeah.
Yeah, he's there.
I'm looking particularly at impact of 5G on geographical information systems. I'm connected with this field a little bit, and as you are aware, this is a platform which will be required for almost every application that we have. So, how specifically? Firstly, in the rollout of 5G, how will geospatial affect, and then how will the applications of geospatial be affected by 5G? So, maybe this is another topic for another day.
Yeah.
Then another technology which is going to be impacted in the AR VR field is what they call digital twins. So how again digital twins can be used, and particularly again I'm looking from the defense, internal security, and public safety angle. You were shown in your slides that almost half of them related to defense, internal security, public safety, and safety, industrial safety as well. Okay.
Absolutely.
So
Absolutely.
this is something which we need to discuss a little more about. And then one more thing, you are aware that our country is very aggressively looking at indigenization, particularly in the field of electronics. You see, our bill for electronic components import is almost as much as our oil bill. And this is also rising every day. And now here again, when we're looking at indigenization of electronic hardware, so how can we sort of make the change for our MSMEs, particularly that the hardware which is required? You have mentioned that hardware requirement is reducing, and more it is going to be software. And software we are well strong in, but still we will require specialized hardware. Then how can our industry cope with this requirement, particularly the MSMEs? Here again, I'm associated with Encina, which is an organization of about 300 to 400 MSMEs who are looking forward to how these changes should make them change their manufacturing, right? So these are some of the things that we can deliberate upon in future webinars with an expert like you.
Absolutely.
And of course, I will request Professor Huda to give me the contact details of our experts so I can have a one-to-one with him sometime. So with these words, once again, thanking you, Professor Huda, for the human service that you are giving all the students. Thank you very much.
Thank you so much, Chandale sir.
Thank you.
Thank you so much for your encouraging remarks. And certainly, the topics which you have suggested will be taking up in the future. Ajay, we had one webinar on 28th November 2020 on digital twins by Mr. Shubhankar. And I think that webinar with a little different use cases, maybe one of the use case could be from defense.
Yeah,
We may organize next
I'm
month.
particularly
Organize next
interested
month.
in internal security and public safety. How this
Right.
can be achieved, right? For example, how
we
do
will be conducting digital twin as a technology, and then we'll be taking up use cases from defense and internal security. So we can plan it again, Ajay ji,
by the
right?
way,
Sure,
there is
Professor
an
Huda, we'll do
interesting
that.
webinar being hosted by the government of Karnataka tomorrow at 1800 hours on metaverse, which is supposed to be the first webinar of that type.
Correct.
I'm sure it will be an interesting thing. Mr. K.T. Ramarao himself is organizing this.
Oh,
so, he's somebody who's very keen in this field. So for those who are listening in, it would be a good idea to log into that webinar as well.
Sure. We are also planning a metaverse webinar.
Yeah.
Let's see when the date is being finalized. But anyway, we'll attend
Right.
tomorrow. And thank you so much. Thank you so much to everyone. Ayushi, over to you. Go ahead.
Thank you, Ajay sir, for being the motivating force. Thank you so much. I would now like to request Professor M.N. Huda sir to kindly present an e-certificate to Mr. Arnab Das sir as a token of remembrance. Please, sir.
So thank you so much, Mr. Arnav.
Thank you
And
so much.
certificate is not for the purpose of certification, rather is a purpose of remembrance that you have been part of this wonderful webinar, which were attended by so many senior people. And we'll meet again with this webinar.
Thank you. Thank you so much. I'm really grateful for the opportunity, Professor Hoda, and some very interesting topics that you also talked about, digital twins, and also about public safety, about GIS database and how that will be used. So very interesting topics, and I'm really,
Yes.
really happy about the technical orientation of we need this scientific approach in our society more and more. So I'm really, really proud that such initiatives are being conducted. Thank you so much for the opportunity.
Thank you so much.
Thank you, sir. I would now like to present an e-memento to Mr. Arnab Das sir as a gratitude from BVI camp family.
Thank you so much.
Please
Again,
accept
this memento is a part of your remembrance.
Thank you.
Now everything is moving. Everything is moving in online mode. So right
This
from
is,
bouquet, we made it e-bouquet. Let's save environment, and even to memento. Let's do not waste physical and hard things. Let's go online.
Absolutely, absolutely. Maybe we should make it NFTs and something like crypto.
Correct. And my special friend, Mr. Ajay.
Yep. Thank you, Professor Huda. It's been pleasure, and we'll have many more such sessions.
Huda Saab, I'm also Ajay, so I keep wondering whom are you talking to?
Mr. Ajay Goel, Gentleman, sir. I can
I'm
claim you
also
a friend,
Ajay.
but I will always tell you Chandele, sir.
All right. Thank you.
Right. So thank you so much, dear participants. The feedback link has already been posted, and all of you are requested to please fill up this. Once you fill up, automatically